Let's look at a question. I'm going to take my time with this and I'm going to do it carefully and clearly. I'm going to draw a diagram. I'm going to show my working. I'm going to ask you to do it like this every time. So the question is, television tubes use magnetic fields to deflect the beam of electrons. Electrons are emitted from the electron gun in the tube at a speed of 2 × 10⁷ meters per second. They travel a horizontal distance of 20 centimeters to the screen and are deflected sideways by the magnetic field a distance of 10 centimeters. Calculate an approximate value for the flux density of the magnetic field to do this, given that the mass of an electron is 9.1 × 10⁻31 kilograms. Okay, so televisions don't use tubes these days, I know, but it's still a valid question that you might come across. Alright, so the steps are: Step 1. Sketch the question. Step 2. Work backwards to decide how to answer the question. Like, what equations do you know to help you? Step 3. Calculate B. Here is my drawing then. Let's draw a dashed line to start with, showing the path that the electron would normally have taken. I'm going to say that the electron is deflected downwards, so I'm going to draw a curve, a bit like a normal trajectory line, since we're dealing with magnetic fields. It's travelling at 2 × 10⁷ meters per second. It travels horizontally 20 centimeters, and it is deflected 10 centimeters. And that's my drawing. It might not seem like much, but it didn't take me long either, and it is going to help me to think about the problem. Step 2 was to work backwards to decide how to answer the question. So, what equations do you know? I won't wait, because hopefully you're very quickly coming up with F equals BIL and F equals BQV. So let's look at those two. For F equals BIL, we can rearrange it to B equals F over IL. We know L, but we don't know I or F. So this might not be the best equation to use. We have another equation, so let's have a quick look at that first. F equals BQV, so B equals F over QV. We know Q and V, but we don't know F. Now this is looking better as there is only one unknown, and looking at what we do have, we have M, and everyone knows that we can relate the force to the mass. This might work. Right, so now we are on to step 3. Calculate B after calculating F. So let's use F equals ma. We know that t equals distance over speed. So just looking at the horizontal direction, that's 0.2 over 2 × 10⁷. B is acting downwards, so let's find the vertical acceleration. We have s as 0.1 meters and t as 1 × 10⁻⁸ seconds. So using s equals half at squared, a equals 2 × 10⁻15 meters per second squared. Lastly, F equals ma, and then look up the mass of an electron, 9.1 × 10⁻31 kilograms, giving F equals 1.8 × 10⁻15 newtons. Nearly there. We still need to find B. So, F equals BQV, so B equals F over QV, lowercase v, remember, we have F equals 1.8 times 10 to the minus 15 newtons. Q equals minus 1.6 times 10 to the minus 19 coulombs, as it's an electron. And V equals 2 times 10 to the 7 meters per second. We were given that, giving us, in the end, B equals 0.56 millitesla. That seems tiny, but considering that the strongest magnet ever created on Earth was 45 Tesla, then you'll see that 1 Tesla goes a long way. Now, hopefully you followed along with that, and you took note of not only what the answer was, but of the steps that were used, so that you can follow steps like that every time you try to tackle one of these questions.